Mrs. Jones is pouring orange juice into 4 identical glasses for her 4 sons. She fills the first 3 glasses completely but runs out of juice when the 4th glass is only 1/3 full. What fraction of a glass must Mrs. Jones pour from each of the first 3 glasses into the 4th glass so that all 4 glasses have the same amount of juice? 1 glass, 2 glass, 3 glass, 4 glasses. So we got 3x, 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 and x according to what they tell me in the question. And then if we add this all up, this is actually 10x. So if we want all 4 glasses to have equal, they've got to have 10x divided by 4 each, which is 2.5x. So what we want basically is each of them to have 2.5x. So how do we achieve that? Well, we achieve that by throwing in 0.5 from each of these to the one that currently has x. So if we do that, then we will get that 2.5 distribution. So basically what that meant is that we were taking 0.5x away from the full glasses. So 0.5 out of the 3x is how much we had to pour, and that in terms of a percentage or a fraction is 1/6. And that would be choice C. Carlos went to a sports store to buy running shoes. The running shoes were on sale with prices reduced by 20% on every pair of shoes. Carlos also knew that he had to pay 7.5% sales tax on the discounted price. He had $43. What is the original before discount price of the most expensive shoes he could afford to buy? Let's say the price is P. After the discount, it's 0.8 P, right? Because 20% off. And then the tax, you'd have to add 1.075. That's 7.5%. And that we want it to equal 43. So basically that is the equation based on the information in the question. So this becomes 0.86p is 43, and then when you divide through, you get p equal to 50. So $50 is the most expensive pair of shoes in terms of its original price. So B is the answer. A 3, 4, 5 right triangle is inscribed in circle A. 5, 12, 13 right triangles inscribed in circle B. What is the ratio of the area of A to area of circle B? So let's draw circle A, and we've got a right triangle inscribed in there. And then circle B obviously a bit bigger, and we got another right triangle inscribed in there. So the fundamental property is that if you have a right triangle inscribed, that means that this is the diameter right there. These are the diameters. So 3, 4, 5, let's label it. That's 3, that's 4, and that's 5. So that diameter is obviously 5. 5, 12, 13, that's 5, that's 12, and that would be 13. So the ratio of the areas would be pi r squared over pi big R squared. Pi's cancel, so it would just be r squared over big R squared. The r in this case, the smaller one, is 5 over 2 because the diameter is 5. And the r in that one was 13 over 2. So if you do this math, it'll be 25 over 169. And that is choice D. Jackson's paintbrush makes a narrow strip with width 6.5 millimeters. Jackson has enough paint to make a strip 25 meters long. How many square centimeters of paper could Jackson cover with paint? So we have this big long strip. Obviously, I'm not going to draw 25 meters worth, but it's like that. It's like a rectangle, right? And this side is 6.5 millimeters, and the big long length is 25 meters. Now, they want you to figure out the area in square centimeters, so we're going to have to convert this to centimeters. So you divide by 10 to convert it to centimeters, and then to convert that to centimeters, you'd multiply by 100. And then the area would just be this times that, length times width. So it'd be 6.5 over 10 times 25 over times 100, and it'll be centimeters squared. So that makes 10, so you just have 6.5 times 25 times 10, and when you multiply all those numbers out, you get 1625 centimeters squared. That would be choice C. You are playing a game. A 2x1 rectangle covers 2 adjacent squares, oriented either horizontally or vertically, of a 3x3 grid of squares, but you are not told which 2 squares are covered. Your goal is to find at least one square that is covered by the rectangle. A turn consists of you guessing a square, after which you are told whether the square is covered by the hidden rectangle. What is the minimum number of turns you need to ensure that at least one of your guessed squares is covered by a rectangle? Let's draw one of these shapes and let's see what we have. So let's say my 2 by 1 is here. Okay, let's say I'm a terrible guesser. So I guess this one wrong. I guess this one wrong. I guess this one wrong. 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 Wrong again. Wrong again. Finally, on the 8th, I'm guaranteed to get it right. So at first you think, okay, the answer must be D, right? But it's AMC, right? So it can't be that easy. So let's see if we can get less than 8. 8 is actually the biggest answer. Let's see if we can get less than 8 by a different strategy. Okay, so let's again draw the same 2 by 1. The key to this question is to understand or realize that this 2 by 1 rectangle, no matter where it's placed, it will always cover an edge square. So these are the edge squares, these guys. The one in the middle you can call center. The one on the corners, I guess obviously you call corner squares. But the edge squares are always going to be covered by a 2 by 1. Try it, you'll see. So therefore, you really only have to guess the edge squares. So for example, if I guess there, that's wrong. I guess there, that's wrong. I guess there, that's wrong. There, guaranteed on the 4th guess, if I concentrate just on the edge squares, I will land in that 2 by 1 rectangle. So I only had to do 4 if my strategy is better. And therefore that is choice C. When the roots of the polynomial below are removed from the number line, what remains is the union of 11 disjoint open intervals. Of how many of these intervals is P positive? So let's draw the number line. And the roots looks to me like if you set this equal to 0, x minus 1, x minus 2, x minus 3, and so on all the way till x minus 10 to the power of 10. It looks to me that the roots are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So those are the roots. 4, 3, 2, 1. Now, if they're removed, they're going to be 11 intervals. So let's see here. This is the first interval. Second, third, fourth, fifth, sixth, 7th, 8th, 9th, 10th, and then 11th is 10 onward, and this one was, I guess, anything less than 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so we got those 11 intervals, and remember, these guys are all removed, so I'm going to put a little open circle to show that those guys have been removed from the number line. And they're saying, in how many of those intervals is this positive? Okay, so that means we have to kind of discuss that in detail before we start plugging in numbers. Okay, so first let me just write it out. X minus 1, x minus 2, and so on. So now let's discuss this. Anything that has a power that is even, so an exponent that is even, is always going to be positive. So for example, this guy here, no matter what you put for x, because you're squaring it, it's always going to be positive. The same story holds true for this guy, for this one, and for that one. So those ones will always be positive no matter what number you put in this whole 11 open intervals. Regardless, it'll always be positive. Those are always going to be positive. So what we really need to concentrate on is just the other stuff. So the x minus 1, the x minus 3, and the x minus 5, the x minus 7, the x minus 9. And that's it. Those are the only ones we need to concentrate on. Okay, so let's do that. And let me write on the side our intervals. And those intervals from upstairs are The first interval is the one that's here, that one, and that's the less than 1. The next interval is I guess, I've got to look at these ones and decide what I'm going to do instead of looking at the number line, actually. So I'm going to look at this interval next. So the one that goes from 1 to 3, and then 3 to 5, and then 5 to 7, and then 7 to 9, and then greater than 9. So 1, 2, let me use a different color, actually. So 1, 2, 3, 4, 5, 6, right? Greater than 9? Yeah. Okay, from those 6, how many of these are going to be positive? All right, here we go. So if I have less than 1 and I plug it into here, so whatever, 0, this will be negative, 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 and when we multiply it all together, it'll be a negative, I believe, right? Yeah. Okay, so that is negative. If I go to the next interval, 1 to 3, so like 2, for example, this will be positive, but all the other ones will be negative. And then the end result will be positive because you're multiplying a positive times a negative times a negative times a negative times a negative. You guys understand. The next interval, 5 to 7, let's say, so 6, let's say, that will be positive. Well, hold on. Let me, before I jump the gun here, let me just see if I'm doing this the right way. This one was, I think I skipped one. Yeah, I got to do this one next. Oh, 3 to 5, so 4, let's say. If it's 4, this will be positive, this will be positive, and then this will be negative, negative, negative. And that will result in a negative. Okay, now I think I have to make sure I put this on the right line. I'm getting lower and lower. Okay, 5 to 7, if it's 6, for example, this will be positive, 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 negative, negative. 7 and 9, it'll be positive, 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 negative, and then greater than 9, positive, 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 positive. So let's summarize this. This one would be positive, this one would be negative, and this one would be positive. Okay. So now we go back to the original question. How many of those 11 are positive? Well, this interval is, this interval is, and this interval is. So let's go back and see what that means on the graph. So this was 1 to 3. So from 1 to 3, we have this interval and that interval. So those are 2 intervals for which, of the original 11. And then we have this guy, which is between 5 and 7. So 5 and 7 is this guy and this guy. So another 2 intervals. And this one is, let's see here, greater than 9. So this interval and then the infinite interval. So we have 1, 2, 3, 4, 5, and 6. 6 intervals for which p at x is positive, and therefore the answer would be C. The answer would be C. How many integers n does the expression represent a real number where the log denotes base 10 logarithm? Let's see if we can simplify this. Let the log of n equal a. So that expression basically becomes, well, this expression initially, it's the log of n squared, but we can put the 2 out front like that, and then it will be the log of n all squared, and then the rest is the same. By making that substitution, I can make it as 2a minus a squared over a minus 3, all under the square root sign. And that expression can be further, let's see, if I factor out at a be a, or sorry, it'd be 2 minus a, all over a minus 3. And I think that's about as far as I can go. So now let's talk about when. The key is we have to make sure that n is an integer. Okay, so we have to make sure that n is an integer. So let's not forget what that substitution is. So I think we're going to have to look at certain intervals and the number line. So there's 0, there's 1, 2, 3, minus 1, minus 2, and so on. So the first interval, let's see here. Let's go there so that when a is less than 0. The next one, when a is equal to 0. The next one between, when a is between 0 and 2. And then the next one between 2 and 3. And of course the last one, a greater than 3. And let's see what happens. Okay, so here we go. When a is less than 0, that would basically mean that the log of n would be some negative number, right? So whatever, like some negative number. So that means 10 to some negative exponent is n. And if that's the case, then we're not going to get integer values for n, I believe. Yeah, because for example, if it's negative 1, it'll be 1 over 10. If it's negative 2, it'll be 1 over 100, and so on. So this does not give me any solutions. So no solutions. Okay. So far, so good. Let's keep going. So then a equals 0. That means the log of n is 0. So that means 10 to the power of 0 is n. So therefore n equals 1. Okay, so that's one solution. Just put 1 there as the number of solutions. Because I think at the end they just want how many. So how many would be the number of solutions. Okay. So let's keep going. When a is between 0 and 2, so for example 1, correct? Yeah. But we also got to, I'm concentrating just on the substitution, which is this guy right here. We actually really should be concentrating on this guy right here. Yeah. But so far I think we're doing a good job. When a is in that interval, that basically becomes, for example, if you put 1, it'll be a negative number. And therefore, since it's a negative number, we won't get any no real solutions. Okay, so that one gives nothing. And then how about the next interval? Let me see. Let me go to this one first. If a is greater than 3, then again, we're going to get a negative there, so no real solutions. Okay, so now we're going to concentrate on this guy here. A is between 2 and 3. So since that is representing the log of, since log of n is representing a, we're going to put in that. So 2 is less than or equal to the log of n, 3. So that means basically that n is actually between 10 to the power of 2 and 10 to the power of 3, correct? Yeah. So that means n is between 100 and 1000. So it includes 100 and then 101 like that, but then it eventually goes to 999 because you don't include that 1000. You just, it's got to be less than. So this is a total of 900 values. So 900 goes there. So the grand total would be that one plus that 900, which would be a grand total of 901. So 901 is the answer, and that's E. How many non-empty subsets of B, 0 to 12, have the property that the number of elements in B equal to the least element of B? For example, B is equal to 4, 6, 8, 11 satisfies the condition. So let's try to understand this question. In this, the least element, which is 4, is equal to the number of elements, which is 4. Okay, sounds pretty straightforward. So I think we have to do this in steps. So how about we have number of elements in the subset, and then we'll take it case by case. So let's say the number of elements is 1. So that means that our subset would just be 1. That's the only possibility. So total subsets, I guess, just 1. Okay. How about if the number of elements is 2? Then I hate drawing those symbols. I'll just draw brackets. It just makes it a headache for me to try to make that shape. So we have 2 this time elements, but this guy can be, let's see here, how many are there total? There's property that B elements, for example, satisfies the condition. Okay, so the key word here is least. So that means the second number has to be greater than 2, and the numbers range from 0 to 12. So that second number can be anything from 3 to 12, and that is 10 possible choices. So from those 10, I can choose 1 to fill that second element. So that's 10. Yeah. Okay, let's keep going. 3 elements this time. 3 and then 2 additional elements. Correct? And these additional 2 elements can be anywhere from 4 to 12 because they have to be greater than 3. So that is a total of 9 elements. So from those 9 elements, choose 2. So that's 36. 4 elements, 4 and then 3 additional elements. And these numbers can be anything from 5 to 12, which is 8. So from those 8 numbers, you can choose 3. And that's 56. Okay, I think I'm on a roll. So 5 elements, that would be in a very similar way. 5 and then 4 additional numbers. And these guys can be anything from 6 to 12, and that is 7. And from those 7 numbers, I have to choose 4. And 7 choose 4 is 35. And then 6, so 6 and 5 additional numbers. So those numbers can be anything from 7 to 12. And that is 6 numbers. From those 6, I have to choose 5. And there's 6 ways. And then finally 7. 7 plus 1, 2, 3, 4, 5, 6. And those numbers can be anything from 8 to 12. But I think I run out of numbers there because that's only 8, 9, 10, 11, 5 numbers. So even if I put all of them like this, I ran out of numbers. So this one is invalid. So it's just those ones up there. So you add them all up. The 1, the 10, the 36, 56, 35, and 6. Those are the number of subsets. The grand total is 144 when you add those up. And 144 is D. What is the area of the region in the coordinate plane defined by the absolute value of x minus 1 absolute value plus absolute value of y minus 1 absolute value is less than or equal to 1? Okay. Well, we are going to unfortunately have to graph this. But let's first concentrate just on the first quadrant. So the first quadrant is a scenario where x is greater than 0 and y is greater than 0. If that is applied to that, it reduces to x minus 1 absolute value plus y minus 1 absolute value, and I think that it'll be less than or equal to 1. That doesn't change. Okay, so now how do I graph this? All right, so I guess I'll just do it in the very basic way. Just plot some points. Let me just stick to the basics here. Integers, when it's 0, it will be 1, and therefore this is going to have to be 1, right? Oh, but the fact is that it's less than. Well, less than or equal to, and I'm just doing equal to. Yeah, because what I'm doing is just this guy here. I'm doing this one. because when x is 0, it would be 1. And then y, hold on, I forgot another. Y would have to, let's just do the equal, and then I guess it'll be in a range. So let me just do it and plot it. This will be 1 and 0, 1 and 2, and then 2 and 1. Those are sort of the boundaries, I think. So let me plot this now. So we have 0, 1, 1, 0, 1, 2, so up here, and then 2, 1. So these are the boundaries. So if you connect them, that will sort of be the range in which this holds true. Okay. All right, that's very good, I think. And then therefore we have to do that for the other 4 quadrants. The other 4 quadrants are x greater than 0, y less than 0. Then the other one would be x less than 0, y greater than 0, and then of course both of them less than 0. And when you do that, and I'll let you do that, it'll be exactly the same in terms of the shape. Very similar, it's just in a different quadrant. And what they want, I believe, is the total area. Okay, well, since they're exactly the same, we'll just calculate the area of that one and then multiply by 4. Well, this was, from here to here was 1, right? And from here to here was 1. So using Pythagoras, you can easily figure out that that's root 2. And therefore, this is all root 2. So that means that's a square with side root 2. So its area would be root 2 times root 2. So that looks like 4 times 2, which is 8. And therefore, B is the answer to that question. In the xy plane, a circle of radius 4 with center on the positive x-axis is tangent to the y-axis at the origin, and a circle with radius 10 with center on the positive y-axis is tangent to the x-axis at the origin. What is the slope of the line passing through the 2 points at which these circles intersect? Let's draw a diagram if we can. So the first one is going to be something like this. Something like that. So this is the x-axis. The y-axis, and like they say, that is tangent to the y-axis, and it's got its center on the x-axis, correct? Center on the positive x-axis, tangent to the y-axis. And then the other circle is similar, but this time its center is on the y-axis, and so this is 4 in terms of the radius, so that radius, oh, that's much bigger radius, so something like this. Something like that. Okay, I think that's pretty decent. Not the greatest, but it's okay. And now what they're saying is, you've got to figure out the slope of the line that cuts through the intersection point. So that line. Okay. I think shouldn't be too much of a problem. Okay, so let's see here. First, you guys remember a little bit of a primer for those of you who forgot. If the center is at the origin, that would be the equation of a circle. But if the center is not at the origin, the center is hk, then the equation becomes x minus h squared plus y minus k squared, like that. And r squared is the radius squared. So in the small guy, the center is 4, 0, correct? Yeah. So that means the equation of that smaller circle would be x minus 4 squared plus y squared is equal to r squared. And then for the bigger circle, that center is 0, 10, I believe. And therefore that equation would be x squared plus y minus 10 squared is equal to r squared. So we have to solve these equations, and that shouldn't be too big of a deal, these two. Okay, so first of all, what am I going to do here? I'll just let them equal to each other and then expand them. So x minus 4 squared plus y squared is equal to x squared plus y minus 10 squared. So x squared minus 8x plus 16 plus y squared is equal to x squared plus y squared minus 20y plus 100. X squareds cancel, y squareds cancel, that's great. And let's see here. What else? If I did this correctly here. I didn't do it correctly because these r's are not equal. So that's r squared, which is the big R, that's 100, and that's small, so that's 16. So I was somewhat, that's okay, I can still manage. If I put it all on one side, it would basically be that minus 16. And if I put all this on one side, that'll be minus 100. Yeah. Okay, and then I can easily, solve that. I was just wondering, what did I do? I think this is because I used the same symbol. I should have used a big R. That's okay. Okay, so that basically means that we have 8x is equal to minus 20y. Okay, so 8x is equal to 20y. And therefore, 4x is equal to 10y, or 2x is equal to 5y. So the slope of that line is really just rise over run, where that's y and that's x. So the slope is basically just y over x. So if we take that and just put y over x, we get 2 over 5. And that's it. That's basically the slope. So that would be choice E.